For decades, doping has been this dark cloud just hanging over elite sports. We've thrown everything at it: super sophisticated testing, lifetime bans, you name it. And yet, the problem just doesn't go away. It's this endless cat and mouse game. But what if we've been looking at it all wrong? What if the solution isn't just better tests, but a better game?
I mean, it's the fundamental question, right? We see these athletes who've dedicated their entire lives to their sport, and then they cheat. We usually jump to the conclusion that it's a moral failing, a simple choice between right and wrong. But the research we're digging into today, well, it suggests there's something much deeper and honestly way more logical going on. See, the big idea here is that for a lot of athletes, the choice to dope isn't really about being a bad person. It's about getting caught in a strategic trap. And if you know anything about game theory, you've probably heard of this one. It's the classic prisoner's dilemma. It's this wild situation where everybody making the smartest choice for themselves ends up creating the worst possible result for the group. Okay, so to really get our heads around this trap, we've got to start with the basics. Let's break down the fundamental strategic choices that every single athlete is staring down in this incredibly high-stakes environment. All right, here we go. This is the classic doping game in a nutshell. You've got two athletes, A1 and A2. Each has two simple choices: dope or not dope. All those letters in the boxes just represent the potential payoffs, the glory of winning versus the risk and cost of getting caught. But the real magic happens when you start to compare these outcomes. Okay, now follow the logic here. Let's say you're athlete 1. If athlete 2 decides to dope, what's your best move? Well, you pretty much have to dope too, just to level the playing field. But what if athlete 2 stays clean? Your best move is still to dope because then you get a massive advantage. You see the problem? No matter what the other person does, the single most rational choice for you is always to dope. And this leads us to a super important concept in game theory called the Nash equilibrium. All that really means is it's a point where nobody can do better by changing their strategy, as long as everyone else stays the same. It's a stable outcome. But, and this is a huge but, stable does not mean good. So, all of this leads to a pretty depressing conclusion. The only stable outcome, the only Nash equilibrium in this game, is that top left box. Both athletes dope. They are both way worse off than if they had just cooperated and stayed clean. But the cold, hard logic of the game traps them in this inevitable race to the bottom. But what if we could change the rules of the game? This is where the paper we're exploring gets really cool. It introduces a fascinating little twist. What if one athlete could credibly announce their strategy before the competition, turning it from a simultaneous choice into a sequential one? So here's the question. Does getting to go first actually break the trap? If you could publicly declare what you're going to do, would that be enough to change your opponent's calculation and change the whole outcome? What do you think would happen? And the answer is surprisingly no. It feels counterintuitive, but the math is clear. Even if athlete 1 announces, "Hey, I'm staying clean," athlete 2 will just see an opportunity and choose to dope to get that easy advantage. And since athlete 1 knows this, they're still forced to announce dope just to keep up. The trap holds. Okay, but this is where the whole analysis gets really, really interesting. So far, we've assumed both athletes are identical. But what happens when we inject a dose of reality? What happens when we account for the fact that the consequences for getting caught are totally different depending on who you are and where you're from? Right, so that first model is a symmetric game. Everyone's facing the same payoffs. But the real world is asymmetric. The prize money might be the same, sure, but the cost of shame, the public stigma of being branded a cheater, that can vary wildly from one culture to another. And this quote from the source really zeroes in on the key variable: stigma. We're not just talking about fines or bans here. We're talking about the crushing weight of national shame, a powerful cost that's deeply embedded in a country's culture and identity. And this is a perfect real-world example. In 2001, the Finnish cross-country ski team was at the center of a massive doping scandal. The national disgrace was so profound it had a chilling effect on the entire sport for a generation. I mean, just look at the numbers here. Before 2001, they had 8 Olympic golds in 7 games. In the 7 games after, only 3. The cost of that stigma was devastating and long-lasting. So, we have our key ingredients: a sequential game and asymmetric costs. Now, let's put them together, because this is where the paper uncovers a truly startling possibility, a potential pathway out of the doping trap. This is the million-dollar question. What if the game is set up so that the athlete from the high stigma culture, the one with the highest potential cost of being caught, What if they get to be the first mover and announce their strategy? And here, the logic completely flips on its head. Let's walk through this carefully. First, Athlete 2, our high-stigma athlete, gets to announce first. They think ahead. They know if they announce dope, Athlete 1 will just follow suit. But for Athlete 2, that's a terrible outcome because of that huge cultural cost. So they consider the alternative. If they announce no dope, what will Athlete 1 do? Well, their best response is to also stay clean to ensure a fair race. And knowing this, Athlete 2 makes the only logical choice for them. They announce no dope, locking both athletes into the clean outcome. And there it is. The game is transformed. By changing the sequence and acknowledging the real-world costs of stigma, a new, stable equilibrium emerges. No doping. It's a remarkable theoretical result. The idea that a simple announcement, under just the right conditions, could potentially eliminate doping. It's pretty mind-blowing. Now, before we declare the problem solved forever, the paper brings us back down to earth. This is a powerful model, but the real world is, of course, a lot messier. Is this beautiful solution actually practical?
Well, the challenges are significant. I mean, how can an announcement be made truly credible? How does the other athlete really trust that the leader won't just cheat anyway? And what's to stop that other athlete from just trying to seize the first mover advantage for themselves? These are huge questions of trust and coordination. And that leaves us with this final, really powerful thought. This whole analysis shows that doping isn't just a problem of individual morality, it's a problem of system design. And it suggests a brand new mission for anti-doping agencies. Maybe the answer isn't just about catching cheaters after the fact. Maybe it's about strategically redesigning the rules of the game itself to make clean competition the most logical, rational choice for everyone.